We've talked about that there's such thing as a first derivative. There's also such thing as a second derivative, which would be the derivative or rate of change of the first derivative. And you could have a third derivative, fourth derivative, and so on with certain functions. So if you have one of these problems where they're showing you a function here, um, and a derivative of it and a second derivative, you should be able to pick out kind of which one's the original function, which one's the first derivative, second derivative, even without maybe these being here to tell you, you should be able to find out which one's which. So what you're doing is a lot of those little tricks we used on the previous video to find some things out. For example, look at our first derivative. We know there the slope is 0, so what do you see on the first derivative graph? That you have a point at 0. Over here we have another tangent line that would be 0, so what do you see on the derivative graph? 0. Some other stuff to notice here, the connection between that pink and blue graph. Look at the slope in this region. It's slanting up, so it's positive. So what are all these points here? They're all above the x-axis, indicating positive. In this region, all the slopes are negative. So what do you notice about all the points on the blue graph? They're all below the x-axis. Now this graph again goes back to slanting up, so we have positive points being graphed there. Now if you look at the connection between the blue and gold one here, same thing. What's the slope here? 0. What do you have here on that gold graph? A point at 0. All positive slope, we see points above the x-axis. All negative slope, all points here below the x-axis. So you can come up with those derivative graphs from the previous one. If we wanted to, we could even find a third derivative here. This graph, just kind of estimating here, looks like it goes up 1 over maybe a fourth. So what would that slope be? Up 1 over 1/4. If I multiply by the reciprocal, that slope is going to be a constant of 4. So if I wanted to graph out the the third derivative here, wherever 4 would be, probably up here somewhere, there's 2 there. So up here where 4 would be, the third derivative would just be a constant line going through that point. That would be the third derivative. If you wanted to find the fourth derivative of this, the slope of this line is always 0, so the fourth derivative would just be right there at that line. So that would be the fourth derivative here. And usually with notation, one last thing, usually with notation, once you get above the second derivative, or maybe third, they usually indicate it like this with a parentheses and what the derivative is. So you should be able to find higher derivatives also with functions.